All right. Shh, shh, shh. All right, guys, hush. All right, so page 15, yeah. All right, so factoring using the AC method, that's another name for T method. All right, so AC method is another name for T method. But we can also do that using reverse box as well. So again, this is more kind of the same. There's just an extra step to it. All right. So biggest thing is, I don't care which way you do it. I'm going to show you both. It's up to you to pick a method that you like better or that you're more successful at and then use that method. It's not going to be on the test. I'm going to tell you to solve this by reverse box. No. I'm going to tell you to solve. The only thing on the test I'm going to tell you to do is solve it using a certain method, specifically factoring, quadratic formula, completing the square, whatever. But factoring methods, I don't police that. All right. So factoring using the AC method or reverse box. So these are pretty much all the same for both reverse box and AC method. So the AC method is a strategy used to factor trinomials. So remember, trinomials are expressions with three terms. And it's an unway of doing FOIL or box. So AC method undoes FOIL, reverse box obviously undoes box. So you take your three terms and strategically break it up into four terms from FOIL or your box. So this is where we use what we call big X. And we always factor in quadratics in its proper standard form. So ax squared plus bx plus c. So let's do a GC, or not GCF. Let's do a quick example just to kind of show you how to do it. So let me just pick one here. So let's do 4x squared minus 16x plus 12. Now, very first thing you should do, and this is true for any factoring, you look for the GCF of all terms. So if I look at this, is there a GCF? Yep, it is 4. So we're going to go ahead and take that 4 out. So what would that leave me with? Good. Now, why do I do this? You always need to factor out GCF if you can, because it's the difference between having to deal with really big numbers versus having to deal with smaller numbers. Then you list all the factors of AC and their sums and find the pair of factors that adds up to B. So this is where big X comes in. So some of you may or may not be familiar with this. So with big X, on the top, you do A times C. So if you label it A, B, C, you're going to multiply A times C. On the bottom, you're going to put your B value. And on each side is going to be your two factors. Now, I've discovered that sometimes adding something like an x squared at the end and the x helps because these factors are going to end up having x's after them. Because what we're going to end up doing is creating factors to replace this negative 4x right here. So when we put in A times C, we want to multiply to that value and add to whatever the B value is. That's what the two numbers should do. So it has to fit two different criteria. So first off, what is A times C? 1 times 3, so 3, and then I throw in an x squared at the end because of the A. What's my B value? -4, and then throw in an x. So why do I include the x squared and the x? Because I know that these values are going to have x's on the end because they're replacing the -4x. But, and remember, x times x is x squared, and if you combine like terms, you have to have both x's to add to a -4x. Now, we're going to list factors of 3 that will add to -4, what's the only factors of that? -1 and -3. And how do we know they're both supposed to be negative? Also, because we're multiplying to a positive number, but adding to a negative number. So, since it's multiplying to a positive, that means both signs have to be the same. And we're adding to a negative, so that means both signs have to be negative. So I'm going to put 1 and 3. Now, from here, we're going to split the middle term using our 2 factors. So I'm going to take these 2 factors. This is why I wrote x's after them. And I'm going to use them to replace the -4x. So essentially, I'm turning this into a factoring by grouping problem. So I have x squared minus 1x minus 3x plus 3. And again, it doesn't matter which way you do it. All right. Now, from here, I'm going to show you the 2 methods. So T method for 1, and then reverse box for the other. So up until this step, everything that we've done up top, you'll do for both methods. All right, so do the big X, break it apart, factor out GCF if you have to, things like that. So for the T method, I'll do that first. I'm going to rewrite it over here. So x squared minus 1x minus 3x plus 3. So I'm going to draw my line right down the middle and then my line under it. Yes, sir. No, you could have put the -3x first and got the exact same thing. So we can't do that because -2x and -2x, they may add to -4, but does -2 times -2 multiply to 3? Because think about it. If we FOIL this back, all right, so once we get our factors, if we FOILed it back, it's going to have to end up being exactly what's right here. All right, so let's say that we had -2. That would give us x minus 2 times x minus 2. If I did a quick FOIL on that, I'll get x squared minus 2x minus 2x plus 4. First off, automatically didn't give us that 3. So these don't match. So that's why we can't just pick any numbers. They have to satisfy both conditions. They have to both multiply to the top value, the big X, but add to the bottom value. Does that make sense? So, T method. What's my GCF of the first group? X. So when I factor that out, what am I left with? X minus 1. What's my next step? Bring down that negative. So this GCF is going to be negative. And what is that GCF? -3, which leaves me with what? X minus 1. So one of my factors is guaranteed what? X minus 1. Because the 2 bubbles, they have to be the same. What am I left over with? X minus 3. Now, here's how you can check yourself to see if you're right. All right. Just do a quick FOIL or box method back. So if I do first, that's x squared. Outer, that's -3x. Inner, that's -1x. And then last, that's +3. Combine like terms, I get x squared minus 4x plus 3. That's exactly what I had when I started up here in the parentheses. Yes? Technically not, but I want you to get into this habit of this method, at least for right now, just because as soon as we throw in values of A that are bigger than 1, you're going to have to do those. So I'd rather you practice them with the easier ones now, because when we get to, like, say, example B below, you're going to have to use the T method in reverse box. So is it necessary for when A is 1? No. You could technically go straight into writing x minus 3, x minus 1. But I'm just practicing them now with you guys because the next one, or the second to next one, you have to use one of the options. All right, so reverse box. Same thing. X squared goes in the top left. Positive 3 goes in the bottom right. I have negative 3x, negative 1x. Again, it doesn't matter where I put them. I could have switched them. What's the GCF of the first row? X. GCF of the second row, take account for the first sign. Negative 1. GCF here. Just X, because the sign of the first box up here is positive. What about this one? Negative 3. This is x minus 3 times x minus 1. Now, there's one thing I'm missing from this factor. What is it? The GCF of 4. So a full factor would be 4 times x minus 3 times x minus 1. So don't forget to bring that GCF down. And again, if you doubt yourself, then yeah, do the quick box method or FOIL just to make sure that you got the correct thing. Because remember, that's what we're undoing. All right, so again, that one was a relatively easy one. This next one's relatively easy as well. At the very least with these, I expect you to do big X. All right, you like if the A value is 1, I at the very least expect you to do big X. After that, it's fine. But that's only if the A value is 1. So this one, there's clearly not a GCF because our A value is 1, so I'm going straight into big X. So again, I have A times C on top, and I usually throw in an X squared. B on the bottom, I throw in an X, and both my factors are going to need an X at the end. What's A times C in this case? 20 X squared. This is A. Oops. C, B, A times C. What's my B value? 9X. So over here, we're just going to list factors of 20. I just want all the factors of 20. I know it's pretty obvious which one it is. So 1 and 20. Good. Now, since both of these are positive, that means both my signs are positive, so they'll stay positive. So I need to add these up and see if I get 9. So remember, you want to multiply to the top, add to the bottom. 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. Which one works? 4 plus 5. So 4 and 5. Now, do you want to see the T or reverse box method for this, or do you want me to just go straight to the factors? So this one you can technically, since the A value is 1, once you get these factors, you can go straight to it. So it would be x plus 4 times x minus, or x plus 5. That's what it would factor to. Now, let's say that you didn't know that. You can always do one of the methods. So let's say I did a quick reverse box. So first off, this would replace the 9x. So this is x squared plus 4x plus 5x plus 20. So that's what's going in my box. This would be x squared, 4x, 5x, and 20. What's the GCF of the first row? X. GCF of the second? 5. GCF of this one? x, GCF of this one, 4. You still get x plus 4, x plus 5. And again, guys, do I expect you to do this every time? No. Like, I've gotten so good at factoring at this point that I can look at it and tell what it's going to be without having to think about it too hard. All right, that's just something that comes with the more you practice it. But if you have an inkling that you can't do it correctly, you need to use one of these methods. Makes your life 20 times easier. All right. Now, this one, I don't care what you say, you got to use one of those methods. Because that A value is not 1, so you can't go straight to factors. And trust me, I've seen too many people go straight, as soon as they do a big X, they go straight to these factors and they are wrong every time. All right? Because of that A value. And the A value also doesn't factor out because that's the only even number. All right? So I'm going straight into big X because there's no GCF. What goes on top? 6x squared. What goes on bottom? 5x. Don't forget, these are both going to have x's. So what are my two different factors of 6? 1 and 6, 2 and 3. Both of these are positive, so I'm going to leave them as positive. So this is 5. Nope, that's 7, but I can actually add. And this is 5. So which one am I using? 2 and 3. So I have 2, and I don't know why I put an extra x, 3. So I'm going to take these and replace this 5x. So I'm going to rewrite this. I have 2x squared plus 2x plus 3x plus 3. Because if you think about it, 2x plus 3x is 5x, so we can replace it. We're just splitting it up. Now, which method do you guys want me to do? Do you want me to do T or reverse? Which one? Okay, I heard box, so I'll do that one. All right, so box. All right, again, we're using the blue polynomial for this. What goes in my top left always? 2x squared, the first term. What goes in my bottom right? 3, the last term. And then the other two, it doesn't really matter, as long as it goes in one of each of those boxes. So, what's my GCF of the first row? GCF of the second row? 3. GCF of the first column? X. GCF of the second column? 1. Remember, if there's no GCF, you still got to pull out a 1. So, my two factors are 2x I would if my pen will break. So 2x plus 3 times x plus 1. So the reason that people get this wrong, if they just try to go straight from big X to the factors, is because the A value is not 1. At some point, you should have a factor in there where there's a coefficient next to the X, and at least one factor. All right? And again, sometimes those coefficients are easier to find than others. So for example, this one was a fairly easy coefficient because it's 2x. The only option you got is a 2x in one and x in another. But sometimes you may get one like 4 or 6 or 8. I almost said 7. I'm like, that wouldn't even. So anyway, those are definitely ones where you have to use big X, especially if you don't have a GCF. All right. Because trust me, you're going to see factoring. Basically, you're going to see it in Math 3. You're going to see it in pre-cal if you take it. You're going to see it in calculus, like any upper level math that you take from here. You're going to see factoring again, but it's going to be more of a prerequisite, not something that they teach. So the more you can know how to factor, the better off you'll be. All right, so let's do some examples. Let's just start off with a hard one. Well, it's not necessarily hard. do E. Yes. Yes. Wait, where's my pass? Oh, we'll write you on board then. So let's start off with 1. Now, if I'm looking at this, can I even factor that? Not factor. Can I take a GCF out? Nope. Go right into big X. So what goes on top? 28x squared. That's A times C. What goes on the bottom? 29x. Both these are going to have x's after them. Now, the factors of this ones are going to be pretty easy. What are 2 multiples of, or 2 factors of 28 that add to 29? 28 and 1. All right. So if I rewrite this, where I'm replacing the 29x, I have 7x squared plus 1x plus 28x plus 4. Now, since I did reverse box for the last one, I'm going to do t for this one. So I'm going to draw my t. What's my GCF of the first group? X. What am I left with? 7x plus 1. GCF of the second group? Plus what? 4. What's left? 7x plus 1. There you go. All right. What's 100% one of my factors? 7x plus 1. Cross those out. I'm left with x plus 4. There you have it. Now, let's say that I had one like letter F. So the A value is 1, so we know that we can go straight to factors if we wanted to. If we wanted to. All right, so what's my A times C? Negative 56p squared. What's my B? Negative 1p. So we're going to put p's after this. So we are multiplying to a negative number. So that means that what has to happen? One's positive, one's negative. So I'm just going to go ahead and mark one of them negative so I know I got to have a negative one. Now, if we're adding to a negative number, which number is going to have to be the negative one? The bigger one. So let's list some factors of 56. What you got? 1 and 56, 7, 8. What else? 4 and 13, 2 and 26. Nope, that's not 26, 28. So that's 2 and 14, not 13. Anything else? I think that's it. So, obviously, if I make all the bigger ones negative, which one works? 7 and 8. This will be negative 8, positive 7. Now, I know that I could go straight to my factors of being p minus 8, p plus 7. But let's say that I didn't. I'm just going to do a quick reverse box. All right. If I wrote these all out, I have p squared minus 8p plus 7p plus 28. Or minus 20. No, minus 56. Not even close. So what goes in top left? P squared. What goes in the bottom? And then the other two just kind of fill in the blanks. What's my GCF of the first? P. GCF of the second? 7. GCF of the first column? P. GCF of the second column, take account the first square. -8. So remember, if the first square that's above or next to the number that you have to write above, or the spot where you have to write the number, if it's negative, you take the negative out. So we still get this. Any questions on the factoring aspect? How do you guys feel about it? All right, now, this whole unit's about solving, so going right back to solving. Once again, we use the zero product property. So all it states is that if the product of two factors is 0, then at least one of the factors has to be 0. Why does that make sense? Anything times 0 is 0. So that's why we can set our two factors equal to 0, because we're saying, okay, what's the value of x if this one's equal to 0? What's the value of x if this one's equal to 0? Because we know one of them has to be equal to 0 for the whole equation to be equal to 0, but we don't know which one. So to do this, you put all the terms on one side of the equal sign in descending order. In other words, you want it to be x squared plus bx plus c is equal to 0. So it should be in standard form equal to 0. You factor it completely, and then you set each factor, so each set of parentheses or anywhere you see an x, equal to 0, and you solve it. So we're just going to do one or two of these. Let's do, on the next page, letter D. So, now, a lot of students tend to ask me, how do I know which side I need to move to the other side? My suggestion is move the side. If your x squared value is positive, move the side that does not contain the x squared. If your x squared value is negative, move the side containing the x squared. You always want your squared value to be positive. All right, so you need to do whatever you have to ensure it stays positive or becomes positive. So for this first one, letter D, what would I be moving? 3 and the negative 7a. How do I move it? Subtract the 3 and add the 7a. Now remember, make sure you're combining like terms wherever you can. So we bring down the 15a squared. What's negative 3a plus 7a? Plus 4a. And then the minus 3 can't combine with anything, so we just bring it down, and it's equal to 0. Now remember, always look for a GCF first if there is one. I would still keep that in the back of your mind to always kind of check for a GCF first, because again, if there is one, it'll make your problem 20 times easier. Is there one, unfortunately? Nope, there is not. If only that 4 didn't exist, we'd be golden. So we got to go straight into big X. What's going to go on top? I'm going to throw the a squared on there. What goes on the bottom? 4a. So that means both these got to end in a. Now, we're multiplying to a negative, adding to a positive. So what has to be true about our signs? The bigger one's positive, and the smaller one has to be negative. So I'm going to go ahead and mark one of them negative, so I know I have to have a negative sign there. Now, factors of 45, go. 9 and 5, 45 and 1, 15 and 3, and that's pretty much it. So if I make all the smaller ones negative, which one will add to 4? 9 and 5, where the 5 is the negative. So I'm going to rewrite the 4a using the 9 and the negative 5. So I have 15a squared plus 9a minus 5a minus 3 is equal to 0. Which method do you want me to use? Okay, I heard reverse box. So What goes in the top left? 15a squared. What goes in the bottom right? -3. And then the 9a and -5a will just fill in wherever it has place. So, what's the GCF of the first row? 3a. GCF of the second row? -1. This first box is negative, so you got to take a negative out. Don't forget that. If the first box, or the one right next to where you would write the number, when you pull it out, is negative, you've got to take a negative out. What about this first column? So just be 5a. Second column, just +3. So what are my two factors? 5a plus 3, 3a minus 1. So this was one where both terms had, well, actually, no, I'm not done because I have to solve. But this is one where both terms had coefficients on them. So what's my next step? Because I got to solve. Set them both equal to 0, solve the mini equations separately. So 5a plus 3 is equal to 0. 3a minus 1 is equal to 0. So subtract 3 to both sides for the first one. 5a is equal to -3. And then divide by 5. A is equal to -3/5. This one, add 1 to both sides. 3a is equal to 1. Divide by 3. A is equal to 1/3. So if I rewrote this, A is equal to the set of -3/5 and 1/3. Any questions? Do I need to do another one, or are you guys good? All right. So you got a new delta math? Get to work. From